Hello, class. What we're going to discuss now is nomenclature of alkanes, excuse me, called bicycloalkanes. Now, we've previously seen alkanes in a ring structure like that, so that would be cyclohexane. But the moment that we stick another ring on it, okay, so let's say if I added that to it. That right there is called a bicyclo compound or a bicycloalkane. And the reason why is because now this ring has two rings. So what we could see here is you could see in blue right here, that six-membered ring right there. Okay. But then what's on the inside? Looks like a five-membered ring, right? And so what we have going on here is we need to be able to draw these molecules, okay? And so you could, so let's just go back and do something simple. Okay. Let's see here. We could just look at cyclohexane, okay? And we could take that molecule and draw it like this. So just draw a little, like a little bit more broader. Boom, boom, and then in like that. All right. So that and that represent the same thing. And the reason why we draw it like this is because when we add that extra carbon right there, so there's a total of 7 carbons in this molecule. We can represent it like this. We can number that number 1, 2, 3, 4, 5, 6. Now this is just for numbering purposes, just so you can see where everything is, okay? This numbering process that I'm doing right now is not for nomenclature, okay? So we see carbon 4 has a carbon that's bonded to carbon 1, like that. Do you see how I put a little gap? So this bond right here, do you see how I put a gap right there? Why is that so important? Is because if, let's draw it where I didn't. Let's draw it like this, okay? What's the difference between this molecule here and this molecule here? Well, this molecule here has 7 carbons. This molecule here has 8. Why? Because every junction is a carbon. So 1, 2, 3, 4, 5, 6, 7, 8. But here you can see 1, 2, 3, 4, 5, 6, 7. That's all there is. So when you draw the rings like this, when you draw this little triangle right there, you have to put a little gap in between it there. Okay. So now what we have here is we have the molecule looking like this. All right, so getting rid of these numbers here. So this is that, representing the same thing. Now let's talk about this bicycloalkane. What's the name of this? Well, it has 7 carbons, right? So we can call it a bicycloheptane, like that. And in a bicycloheptane, we have what's called bridgehead carbons. All right. Bridgehead carbons, like so. And the bridgehead carbons is that carbon there and that carbon there. And we will get to it momentarily. How do I know those are bridgehead carbons? Okay. So we'll get there in a second. But we have, when you look at a compound, it looks a little funky with 2 rings. We call it, 2 or more rings, we call it a bicycloheptane. So the bridgehead carbons are the carbons that join the 2 rings together. So if we look at it in this structure right here, I could view it this way. I could see a ring like this. There's 1 ring right there. And then I could also see this, I can see the second ring right there. So I have that pink ring and that blue ring, and where are they joining together? They're joining together right there. And so that's what we see in this structure right here. This is our bridged head carbons right there. Now, why is this important to find the bridgehead carbons is because when you take a look at another molecule, okay, what if I draw another molecule that looks like this? What's the difference between this guy and this guy? Well, when I look at it, this is a bicycloalkane, and it has 7 carbons. So I could call it bicycloheptane. But when you look at the 2 structures, you can clearly see that they look different. But how can I name them the same thing? If I did, which one would you know I'm talking about? So that's the thing that's that's why the bridgehead carbon is so important, is because now it's going to help us figure out how to actually name it more specifically so I know exactly which one I'm talking about. So if I look at this one on the left, the bridge carbons would be this guy right there and that guy right there, because those are the carbons that are joining the 2 rings together. Now, when we take these molecules, we are going to now use nomenclature to figure out what the name is. Okay? So when we let's look at this one here. What you're going to do is you're going to identify the 2 bridgehead carbons, and then you're going to try to find the longest path that's connecting them. Okay? And so you can start here, and I can see I could go 1, 2, 3. Okay? So that's a path. Boom, boom, boom. Okay? Now within that path that's connecting the 2 bridge carbons, we count how many carbons there are in between those 2 bridge carbons. So we count 1, 2. There's 2 carbons in between this path. So I make that note, mental note, okay, that there's 2 carbons in that longest path. Now, what if I count the other way? There's going to be 1, 2, 3, okay? There's that path. You see that? Now, how many carbons are in between the 2 bridge carbons? There's 1, 2. So there's another 2. Now I find another path between the bridge carbons from this path to that path. And I see 1, 2. How many carbon atoms are in between those 2 bridge carbons? 1. So this path right here. So 1, and then I put a little like that. And so these numbers right here are going to tell us the name of the compound. And so the way we actually name it is bicyclo, and then we use brackets, and then we put in the order the longest paths. So 2.2.1 bicycloheptane, like that. So how would we name this guy? Well, we've identified the bridgehead carbons, and so we find the paths. So let's go starting here. 1, 2, 3, 4. So you don't count the bridgehead carbons. So from there to there, I followed this path. So we have a 1, 2, 3, 4. No, sorry, we don't. From bridgehead to bridgehead, it's 4 carbons. 1, 2, 3, 4, 5. But we only count what's in between. So 1, 2, 3. So we have a 3. And then we could start here and go boom, boom. So that's 1. Or I could have went boom, boom. And that is also 1 carbon in between. So we would call this guy a bicyclo 3.1.1 heptane. So what's the difference between the two? It's the numbers inside those brackets. And those are what's going to show us these numbers right here is showing us the connectivity of these rings. That's the important part. Now let's take a look at a bicycloalkane that has substituents on it. And here we have 1 methyl substituent. So the way I like to name these molecules, I understand that we have a bicyclo. How many carbons are in the ring? And I count 1, 2, 3, 4, 5, 6, 7, 8. So that's a bicyclooctane. Now I know that's not the correct name because I don't have the numbering scheme for the bridgehead carbons, right? So then I need to identify the bridgehead carbons. I see that they're there, okay? Now typically when you name a alkane, you always want to give your substituents the lowest locant number, and that's typically how you do it, but not with bicycloalkanes. What you do is you first figure out what numbers go into those parentheses. All right. And so let's do it here. So we got to find the paths here. So we have something, let's do this one. From this bridgehead carbon to there, what do we have? 1, 2 carbons in between the 2 bridgeheads. So 2. But do I have a path that's longer than 2? Well, what if we went this way? That is 1, 2, 3 carbons in between. And we always just we rank them from largest to smallest. And then we see from this, we can follow this path right there, and there's only 1 carbon, so 3.1. Now we have to kind of memorize this 3, 2, 1 because we're going to follow that path in order to prioritize the locant numbers. So it's telling me to go through this 3 path. So I could start right here. Number that carbon 1, 2, 3, 4, 5. Do you see how this number right here is telling me to follow that path? Once I stop at a bridgehead carbon, I look at the next number, and that says 2. So follow the 2 path. So I'm going to go 6, 7. So I'm following this path back to the bridgehead carbon. There's my 2. Boom, boom, boom. And then it says, now I stopped at this bridgehead carbon. Now follow that path. So right there. So that would be carbon 8. Do you see how I'm doing the numbering scheme by following the path here? I'll do another example to hopefully make this make more sense. So now that I have those numbers here, I see that my methyl group here is on carbon 8. So we can name it. Let's see here. So that would be, do I have enough space here? Let's write it here. That would be 8-methyl right there. Bicyclo. Now we have to do the parentheses. 3.2.1, close parentheses, and then it would be what? 8 carbons, so octane. And I'm going to run out of board space. And you see that I ran out of space, but that's going to say octane. So 8-methyl bicyclo 3.2.1 octane. Now with this one, we see it's a bicycloalkane. We count how many carbons are in the ring. Let's start with this one. 1, 2, 3, 4, 5, 6, 7, 8. So it's another bicyclooctane. Now we have to figure out the paths here. And so we identify that and that as our bridgehead carbon. So let's look at the path. There's 1, 2, 3. We get back there. So there's 3 carbons in between. And it's not commas, it's period. Then we can go 1, 2, right there. So that's a 2, and then 1. Okay. So there's our paths. Now we have to select here a correct path. Okay, so let's do this in colors here. What if I numbered it this way, following 3, 2, 1? So 1, 2, 3, 4, 5, 6, 7. Come back here, then that's 8. Like that, okay? That's one path. What if, why could I have not have done it this way? Why could I not have started here on this bridgehead carbon? 1, 2, 3, 4, 5, 6, 7, 8. Because when I looked at the path in blue, I did 3, 2, 1, 3, 2, 1. I followed that. But I can also follow that in the pink way as well. Watch. That's the third pathway, second pathway, the last pathway. So now we have the blue numbers and the pink numbers. Which ones would you choose? Well, we want to give the substituent the lowest number if we have a tie with numbering the bicyclo ring. Now, when we're numbering the bicyclo ring, we have to follow this path. But if there's 2 ways to go about this path, then you give the substituent the lowest locant number. So that would be the 6, or the pink numbers. So the name of this compound is going to be 6-methyl bicyclo 3.2.1 octane. All right. So that's the nomenclatures for bicyclocompounds.